Hello, welcome to the video. In this lesson, we're looking at section 8.2, where we're going to be proving triangles that are similar by what is called angle-angle. So if you recall from previous lessons when we talked about congruent triangles, there were like 5 different theorems that allowed us to prove triangles were congruent, like side, 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 angle, side, angle, angle, side, and um, hypotenuse, leg, and then it was angle, side, angle. All right, so those were the 5. Okay. In similarity of triangles, there's actually only 3. And one of them is being able to show that you have at least 2 congruent angles with respect to the corresponding angles of 2 triangles. So that's what they're saying here, is that if 2 angles of one triangle are congruent to 2 angles of another triangle, then you can conclude that the 2 triangles are similar. So here they want us to determine whether the triangles are similar. If they are, write a similarity statement and then explain your reason. So the explanation in this case is, can we use angle-angle similarity theorem to prove that these 2 triangles are similar? So in order for us to figure out if those 2 triangles are similar, we have to see if we have 2 congruent angles. So right off the bat, we have 2 right angles. So I know that angle D is going to be congruent to angle G because they're both 90-degree angles. All right. Next, I see one angle C is 26 and one angle H is 64. At the moment, they're not the same, but we have an unknown angle, either E or K, depending on which way you want to look at it. I'm going to use the triangle sum theorem to figure out what angle E is, because I know that the sum of all the angles in a triangle is 180 degrees. So if I took 180, subtracted it by 90, subtracted by 26, I would get 64. So since I now know that angle E is 64 degrees, I now know that angle E is congruent to angle H because they're both 64 degrees. I have now 2 sets of congruent angles, so my explanation is by angle-angle, I know that triangle, so like CDE is similar. Now I got to write this correctly, so it's going to be KGH. So like D and G, they were congruent, so they're in the same spot. They're both in spot 2, and E and H are in the same spot there. So that would be my explanation and my similarity statement. All right, so here it says show that the 2 triangles are similar. Okay, so in this particular instance, for example A, we have right off the bat, it looks like this angle B is congruent to angle C because they're both 52 degrees. There is no other angle that shows that they have the same measurement. But if you notice, this triangle here shares an angle, and that's angle A. So you can say something like angle A is congruent to angle A because of the reflexive property, all right? So now I know that whatever angle that happens to be, I know they're going to be congruent. So now I have one set, I have two sets. So by angle theorem, triangle ABE is similar to triangle ACD. Looking at B, there are no angles measures for these two triangles. The only thing they tell us is that SR and TU are parallel. Well, with that, that does help us. So why does it help us? Well, for one, since we know that these are parallel, I know that this angle here and this angle here are going to be congruent because angle S is congruent to angle U, because since those two lines are parallel, I can say that they are alternating interior angles. The second one, you wouldn't have needed to know that those are parallel, but I do know that these two angles are parallel because of vertical lines. So I can say like angle SVR is congruent to angle UVT because of vertical angles. I have now two sets of congruent angles, so by angle similarity, triangle SVR is similar to triangle UVT. Here it says show the triangles are similar, right? It's very similar problems to examples A and examples B on the previous page. If you have questions on it, please leave me a comment. I'm more than happy to um, solve those problems. But looking at question 3 here, it says suppose that SR and TU, so from the previous example, so this example over here, they're asking is if SR is not parallel to TU in example 2, part B, could the triangle still be similar? And then they're asking you to explain. So if you had that same look, so this is S, this is R, this is V, this is U, this is T, but there's no parallel symbol, so it would just look like this. Well, you would know that these two angles would be congruent because of vertical angles, but because S, R, and TU are not parallel in this instance, I cannot prove that those two triangles are similar. Uh, Finally, here it says a flagpole casts a shadow that is 50 feet long. So this shadow of this flagpole is 50 feet. At the same time, a woman standing near is 5'4", so this is 5'4" and shadow cast for her is 40 inches. What they want us to do is they want to know how tall the flagpole is to the nearest foot. All right, so since they give us inches here, they give us feet in inches, what we're going to do first is we're going to just convert everything into inches, and at the end of it, I'll convert things to feet once we're done. So I'm going to write this as a proportion. So what I know is I know the two shadow values. So I know that the woman's shadow is at 40 inches, and I know that the flagpole shadow is at 50 feet. But if I were to convert that, that would be 600 inches. So if you took 50 and multiplied it by 12, all right, it's going to be equal to, all right, on the top, I know the woman's height, and that is 5'4", and in inches that would be 64 inches, and then it's going to be divided by the flagpole height, which I don't know, and I'm going to call that x. So I'm going to do the cross products here, and I get 40x is equal to 64 times 600, which is 38,400. Divide that by 40, I get 960. So the flagpole is 960 inches, but they want us to find it out to the nearest foot. So I'm going to take 960 divided by 12, which tells us that our flagpole is 80 feet tall. And that is being able to prove triangle similarity by angle. Hope this helps. Till next time.